Section 2.5, Learning Objectives. We're going to state the periodic law and explain the organization of the elements in the periodic table. We'll see that you can predict some general properties of elements based on this. And we're going to talk about the difference between metals, nonmetals, and metalloids. So the periodic table was discovered by Dmitri Mendeleev and Lothar Meyer. Basically what they were doing is they were just looking at elements as they went higher and higher masses, and they noticed that every once in a while there seemed to be a pattern that was repeating. So, lithium and sodium have very different masses, but they have similar properties, and they just kept going along and noticing that there's like this repeating pattern in the properties of different elements. They both published their tables in according to increasing atomic mass, and Mendeleev was actually able to use his table to predict the existence of some elements that had not been discovered yet. And when they were later discovered, this provided a lot of support for Mendeleev's ideas that there was something to this sort of periodicity. Here we can see Mendeleev's original table looks very different than the one that we know today. And anecdotally, Mendeleev, great beard. As we move on, we get to the modern periodic table, and one of the big differences is that we started to move away from mass because we started to realize that the relationships really involve the atomic numbers and that we should be arranging the periodic table according to this instead. And so our modern periodic table arranges the elements in increasing order of atomic numbers, and it groups elements of similar properties into the columns, vertically, the vertical columns in the table. So we can see that we have group 1, group 2, group 3. All of the elements in group 1 are going to have similar properties, just like all of the elements in group 18 are going to have similar properties. And there's some additional level of organization that we have here as far as these guys are our metals, these guys are our metalloids, and these guys are our metals, or our non-metals over here. So what are those? Metals are shiny, malleable, they're good conductors of heat and electricity. Non-metals appear dull, they're poor conductors of heat and electricity. And metalloids have properties somewhere in between. They conduct heat and electricity moderately well, and they possess some properties of metals and some properties of non-metals. So we have some classifications that we use. So we have our main group elements. These are elements that are in group 1, 2, 13 through 18. Then you have your transition metals. You're going to find these in groups 3 through 13. And then we have our inner transition metals. These are the two rows at the bottom of the periodic table, the lanthanides and the actinides. We have some additional names for some of the groups. The first group, for instance, excluding hydrogens, are called the alkali metals. Group 2 are called the alkaline earth metals. Group 15 are the pnictogens. The group 16s are the chalcogens. Group 17 are the halogens. And group 18 are what we call the noble or inert gases. Here we can see a visual representation of that. So we have our transition metals, alkaline earth metals, pnictogens, chalcogens, halogens, noble gases, and down here at the bottom we have the lanthanide and the actinide series.